Hello, everyone. I hope you all are doing fine. Thank you so much for joining us again on week three, day two of our machine learning study jam. Let me introduce myself again. My name is Moin, and I lead the machine learning ecosystem of Hyderabad. Just a minute. Am I audible? Yes or no? Can you guys drop me a thumbs up in the chat if you're watching? Okay, slowly the view count is increasing, so I think I have to wait a bit. But just okay, I'll wait for a couple of minutes for everyone to join, um, or else let me drop a message in the communication channels saying that we are live. Okay. Oops, sorry, I was on mute. Okay, so before we start, guys, of course, we won't be wasting any time. Let's quickly start off. So before we start, um, do you guys know what is today's topic? Just let me know in the comments, guys. So let's see how many of you know what today's topic is. Yep. Okay, so yeah, today's topic is computer vision. Yep, a couple of people said in the comments. Yes, so today is going to be pretty exciting because computer vision itself is a very what do we say, interesting thing, because there are a lot of, what do we say, applications we can make out of computer vision, and it is a pretty exciting thing to work on. So without wasting any time, let's get started. So guys, welcome to machine learning study jam week 3 day 2 of where we are going to learn computer vision. So moving ahead, so far we learned deep learning. What is deep learning? What is neural network? Yesterday I bored you guys with a lot of math, which of course you guys didn't like, and then we saw how a neural network is basically formed, how basically the first layer and then the next layer is formed, which also you guys felt like it is boring, and then we saw some code which did not work. So today I have a pre-written demo for you guys, so that we won't write any code and get stuck in an assertion error. So without wasting any time, let's go ahead. The agenda. So feature engineering was left, which we will cover with Kaggle Learn. So tonight, after this session, I will try to have an AMA, a very short one, but we already have a scheduled one for next Friday, which will be like long. So hold on till the end. I'll definitely try to have one, try to interact with you guys, and Yesterday we were done with deep learning, and today it is computer vision. So also coming ahead, we have two very exciting topics, guys. One is time series, and then there is AI ethics. Because since we started deep learning, we are already into the AI part of uh, our ML study jam. So whatever resources you guys need for Kaggle Learn will be provided. Number two, the kind of assignment, kind of a project which I was talking about, that will be provided as well. So try to hang on till the end, and we'll further discuss about the AMA as well. So, yep, again, reiterating this for the people who joined new, reiterating this for people who did not understand this. This is how you do. Come to the sessions on the weekends. On weekdays, you use Kaggle Learn, and in group discussions in AMA, you ask your doubts and keep practicing. So, moving ahead. Firstly, guys, what is computer vision? I straightly wanted to dive into the topic today. So without any further more discussions, as you guys know, computer vision is a field which is basically related to vision related stuff like image data, video data, or whatever that can be captured. You might say that even temperature can be captured, yes, but I mean in terms of camera and stuff. So anything that is a visual, so anything that comes under vision, so it is an image and a video. So all of this to be processed, to be interpreted, and to be understood, this is computer vision. That's it in very simple layman terms. This is the definition of computer vision. But if we go to what do we say, much technical terms of this, then I would say that computer vision is something that is, what do we say, grabs the context from given visual data. Let's say you have a lot of visual data with you, a lot of images. It tries to grab some context out of it. So that is where um, computer vision is used. So let's say, as you can see in this image, and you might have seen a lot of projects where people have made this very thing, where it detects the elements in a given image, or from a live stream of a video or something. So today I'm going to keep a very simple, concise, and what do we say, pretty easy kind of explanation, so that beginners can very easily understand. So that is computer vision for you. And like I said, the technical side of it as well, um, where a lot of, what do we say, images are fed to an algorithm. It recognizes, what do we say, whatever it is fed. So that is computer vision. Very simple. uh, Grabbing some context out of a image or a video, any kind of visual data. Okay, yeah, much better. So that is computer vision, guys. Moving ahead, uh, why would we need it? So basically, why exactly do we need it? Is it really needed or not? um, Etc, etc. So yeah, definitely we would need it for these kind of applications majorly. um, Starting with object detection and recognition, we all know this because a lot of you are using facial recognition for your phone uh, to unlock, right? So even, what do we say, budget phones nowadays have this feature, which if we say 5 years ago or 7 years ago was, what do we say, alien to us, which was like high end technology for us. Now it is pretty accessible, and what do we say, pretty easy to get. It is in all of our hands. And also, how many of you use Snapchat and Instagram with those filters on, the dog filter, or the filter which puts ears on your face? So a lot of you use it, right? So that is also where computer vision is involved. Basically, it detects what um, it is being fed the video data or the image data, and then grabs some context out of it and then modifies it. So that is one application of it. And then medical imaging, like I discussed earlier as well. I think I discussed it yesterday or maybe in week 2, I'm not sure, but I hope you guys remember I discussed something regarding COVID data, where during lockdown itself, this was made that x-rays were, what do we say, used to see if a person is in the risk of having COVID or not. Lung X-rays, chest X-rays, these were taken and they made an AI algorithm to detect if a person is falling in the risk of having COVID or not, or maybe detecting tumors, etc. So also, I think a lot of you have also made projects on detecting type of flowers, type of leaves, or if there is any problem with the leaf, etc. So basically, like if it is, um, uh, I don't know what they are called as, pest related diseases, plant diseases. Basically, if there is a crop, let's say it's a rice crop or a leafy vegetable crop, if it is infested with pests, it builds some kind of disease. So even that can be detected. So and of course autonomous vehicles, who doesn't know about this? Everybody knows Tesla, everybody knows self-driving vehicles, which use a lot of cameras to detect the street, to detect what lane it is driving in, and especially the traffic. So we all know this one. And of course augmented reality also, just like I said, around 5-7 years back, it was what do we say, a very cutting edge technology, but now it is accessible to everyone. Now even in a lot of filters which we use in social media applications, the augmented reality is being put. So this is like, what do we say, just the tip of the iceberg. These are like the major parts of the applications where computer vision plays an important role. But there are much more applications, a lot of applications, because um, it is a very vast field, which is also having, what do we say, a very good scope. So yep, there can be a lot of applications made out of it. um, Except for these four, there are many more out there. So also, I think a couple of weeks ago, I also came to know that in medical procedures using computer vision, minimum invasive surgeries also can be done. I'm not sure how far it is feasible, but yes, medical field and medical imaging is a area where definitely AI can play a very huge role. A very huge impact can be made um, in that particular area. So these are a few of them. These are a few examples and a few applications where computer vision can play a very important role. And um, these are, what do we say, just the tip of the iceberg, like I said. So let's go ahead. How does it work? Number one, every machine learning algorithm works on data. Everything that comes under AI needs data, and it needs process data. So even computer vision works like that. So basically, in this case, we take image data. So let's say if we have to detect detect what kind of fruit is it. So we need to feed it a lot of fruit data before, and then in the out of sample data, it can detect what kind of fruit it is. So data acquisition, um, by capturing images from various cameras or sensors, or maybe different kind of, what do we say, video streams. um, this is how data can be gathered and then processed. So let's say that I have around 100 pictures of myself in my phone. each of them would be different. Some of it would be blurred, some of it would be not right, some of it would have what do we say, just half of my face. So that would be kind of inefficient data. So that all needs to be processed. So enhancing the image, making the clarity or reducing if there is any grain or blur, or we basically call it noise, right? The all the grain which is there in the picture. So once it is pre-processed, once we have the right data, just like we do for regular data sets, we have NaN values and we have a lot of um, values which don't make sense. So those things will be pre-processed, cleaned, filtered, and then this cleaned processed data would be used for analysis. So just like that, here images are cleaned, filtered, and then sent for analysis. So here now, feature extraction is done if it is unsupervised, if it is uh, what do we say, um, computer vision based, if it is deep learning based, then feature extraction will be done by the model itself. You guys need not worry about feature extraction in image data if you are using computer vision. So feature analysis, basically analyzing the edges, the texture, the pattern, and then what do we say, detecting it. Then like what do we say comes our part where uh, we put our application to use. So this is how it does. So let me again come from the top to bottom, but in terms of our application, let's say our application is to detect um, or else let's say if our application is to detect what kind of fruit it is it a fruit or a vegetable. So firstly, data acquisition of all the images of all the vegetables, fruit, etc., processing them, feature analysis, how does a fruit look like, the edges of it, the texture of it, all the patterns, etc., etc., and then the interpretation of it. So using CV2 or care all the other AI models to classify, detect, and then understand. So basically, grabbing some context out of the given image. So I'm keeping it in very layman terms, and this is how general approach is towards all kinds of what do we say, um, image detections or object detections. This is the general kind of approach that most of what do we say the applications follow. So this is what it is. And then today we have two demos for you guys. One is edge detection and another is contour detection. So um, how many of you know what what basically these things do? Why do we need to detect edges? Why do we need to detect contours? Why is it exactly needed? Do you guys know why is it? Most of you might not know. Let me tell you. So let's say that you have a image of some person. You need to detect who that person is. We never know who that person can be out of the billions of people around the world. So what happens is our computer recognizes the contours. Contours are basically how should I tell what are contours? Mm, basically contours are something like what do we say, outlines, um, but these are not like the original outlines. Like if I take a picture of my face, I don't have an outline on my face, right? So it is like a imaginary outline around my face to detect how my face looks like. So this can boost up our algorithm to detect who that person is, or else to get trained that okay, this person looks like this. So that will be with counters and contours and edges. So even the same for objects. Let's say if I take a iPhone and take a Android phone, and if I detect the edges of it, detect the shape of it, detect the texture and contours, etc., then I'll be able to understand, okay, this is how an iPhone looks like, and this is how a Android phone looks like, or a phone of some different brand looks like. It has this shape. So that is the very reason why edge detection and contour detection is very, very important in CV2 or computer vision based applications. So today we'll be using today we'll be looking at these ones. I have a pre-written code for you now. A bit deeper explanation on what we'll do. Number one, we'll convert the image into grayscale, because we have got nothing much to do with colors, because we'll be just detecting the edges and the contours. So what we'll do is, to reduce the, what do we say, load, to basically make it straightforward for our computer to understand, we'll simply make uh, the image grayscale with the CV2 library, and then we'll reduce the noise. So basically, let's say in the web stream, or else the stream of the webcam, there is sort of noise added. Then it would be a problem for our algorithm to detect the edges. So we'll smoothen the stream, we'll smoothen the image or the stream with something called as Gaussian blur. So I hope if you guys are video editors or photo editors, then you might have known this particular, um, what do we say? I won't call it a trick, but it is some kind of workaround to make an image smoother using blur. So if you have a light blur on the top of a image which is noisy, it would smoothen it. So it is kind of it is exactly that what we are doing. And then gradient calculation. So you might be thinking, what is this guy doing? Firstly, he made the image black and white. He made it gray. Then he's saying gradients. So these are not the color gradients. This is something different. So it is basically the intensity of it. So now let's say if I have a grayscale image itself, then it would have different kinds of colors in it. Even a black and white image has different kinds of blacks and different kinds of white. If I take a image, convert it into black and white, hair would be black, other parts of the image also would be black, but on a different shade. Got it. So here we are simply checking the intensity using something called as Sobel operators. So you might not know what a Sobel operator is. Let me tell you what it is. In easier terms, basically it's a 2D measurement for this kind of gradients which I told. So it is a kind of filter which detects the edges. um, how should I put it in much easier terms? Mm, Basically some operator that detects the smoothness of something. That's it, in a very, very simple term. So if it is a edge or something else, we can use these Sobel operators and detect it. That is one thing. And then the next step, is the edge strong or weak? Simple, very simple. It is called as double thresholding, but just like I have mentioned over here, classifying based on the intensity, is the edge strong or weak. So now, um, I want you guys to imagine a square. Imagine a square. If you draw a square, square would have four sides, right? And 100% strongly, if the square has four sides, only then it will be called as a square. If one side of it is missing, it won't be called as a square. It will be something like a U, or it will be something like another shape. So even to, what do we say, capture an image and make sure that that is properly detected or recognized, identified, segmented, or whatever it is, we need to properly fine tune that image, and fine tune as in finely process that image. So for that very reason, we are making the edges out of it, and for that very reason these edges need to be strong. So that is the very reason why here we are classifying that as strong or weak based on the intensity. That's the very reason I gave the square example. Now, coming ahead, tracking of these edges. Now we classified them as strong or weak. Now tracking them by hysteresis. Um, Again, another technical term, hysteresis. What is it? If you guys might have heard it in your what do we say, college or something, but basically hysteresis is a very simple thing. It clearly means that there is a threshold value. Some areas are above that threshold, some are below that, right? So basic hysteresis is kind of an effect where um, okay, there are a couple of things in the comments. I'll get back to you guys. So at the end we'll take all the questions, not now itself. Once I complete this, at the end we'll have all the questions. All right. So basically, hysteresis in image processing means comparing stuff, comparing stuff to build an intermediary thing, like bridging the gap. That is what hysteresis is. Just like I told, if there is a threshold value, there is something above it, there is something below it. So comparing these two things, the gap will be bridged. Now let's say that in our square which we imagined, there is a small gap. It will compare the whole image. It will say, okay, there is a small gap over here. It will fill it off so that our square will look complete. So this is how stuff will happen. So let's dive into the demo and see how all of this happens. And guys, remember all of these things. I'll explain each and every one of this again in the demo. I'll show how it actually works. So let me present VS Code, or else I'll present my whole screen. Yesterday there was a lot of problem. Also, guys, I have to turn off my camera because I'll be using my live webcam to show you this demo. So I have to turn it off. Just a minute. Yep. Now I'm sharing my entire screen. I hope it is visible for you guys. So I'll open the demo. So I have got three demos for you. One is where we'll be doing the edge detection, um, and then we'll be going for the contour detection, and then I have a emotion detector for you. Um, I hope this one works. So I'll just simply do a control plus. So that. Also, guys, if you don't understand anything, if something is not clear, and if my voice stutters in between, and if the demo stutters in between because of network, just let me know. I'll try to fix it for you. If the font is not big or you guys need something, just let me know. All right? Let me know. So also, can I have a quick thumbs up in the chat so that I can go ahead with this? Guys, quickly drop a thumbs up in the chat. Then we'll go start off the demo. Okay, a bit more, please. Show a bit more love. I hope you guys can do that. Okay, cool. So yeah, let's start off. So firstly, I'll quickly explain the code, and then we'll try to run it. So number one, here I've imported CV2. CV2 is nothing but computer vision. So I'll also show you the library. Uh, yep, here you go. So this is OpenCV, and here will be the documentation. Let me check. Mm, okay, fine. So basically, guys, CV stands for computer vision. We'll be using this library, which would provide us with all the computer vision related stuff, so that we could write some code and make a application out of it. Also, guys, here a very important thing for you: there are free courses on this TensorFlow, OpenCV, Python, absolutely for free. So that's the very reason we organize these kind of things, to give you what do we say, knowledge, which costs nothing. So just like our ML study jam is free of cost, this is free of cost, and there are a lot of things on Kaggle Learn as well, which are free of cost, provided by um, Google itself. So go check these out. um, you guys will definitely like it. So this is one thing, and yeah, let us go back to the demo. So here I'm importing CV2, and here I'm starting the webcam. So basically, I'll start the webcam, and then this is basically a error handling statement, for what do we say, if the camera is not open. And here in this if case starts our whole, what do we say, whole thing. So number one, just like I told, the image will be converted into grayscale, and then we'll be using something called as canny to apply the edges on that. And then um, all of these edges will be differentiated, and only the edges will be seen in the image, not the original image. So without wasting any time, let me show you. I'll go to the terminal, and I'll type python cv demo.py. I made this in just 5 minutes. Just 5 minutes. It is just around like 33 lines of code. So it is a very quick but a very effective demo. I'll quickly run it. Oops. This was running very fine. Okay, let me run it again. No. I really don't know why the demo is not in my favor today. Even yesterday it was not. So I made sure that it runs well. So let me do one thing. Let me reinstall CV2. I already did that. Streamer pipeline, something's wrong. This is the same thing, right? Okay, let me run the other demo. What? Okay, wrong. Oops. Yeah, just give me a couple of minutes. Let me see what's wrong. This is pretty embarrassing for me. It properly worked a while ago, and when you guys are here, when you guys are watching, this fails to work. Yep. Just until then, if you guys have any questions, please put it in the chat. I would love to answer them. Uh, this is basically a environment error. So what I'll do is I'll first uninstall OpenCV, then I'll reinstall it. Okay, guys, thank you for hanging around. I think I have fixed the issue. So let me quickly present my screen and run the demos. Meanwhile, until then, I have the house open for questions. If you have any questions, please ask. Any questions? I'm ready to take any kind of questions related to today's topic, or maybe anything from starting from week one. If you have got anything, please feel free to ask. Okay, I kind of found the issue. So, you guys don't have any questions until the code runs? Not at all. Hello. Yeah, can you guys hear me? Because I had to join from another device because this device will be using the camera. So that is why it was not working. So just a minute. Let me start this thing for you. Okay, perfect. So let me present my screen again. Entire screen. Yeah, so yep, the demo worked, but still, it was late. It made me go embarrassed. Okay, fine. Anyways, guys, so I hope you can see PowerShell and where is the camera one? Here you go. Okay, so don't get scared. Yeah, it is me, but only the edges. As you can see, my face and my hands, only the edges are getting detected. Got it. So this is how it is working. Peace. So let me tell you and also let me walk you through by the lines of code. So as you can see here, where is this? Firstly, we did uh, what do we say? We converted it into black and white image. So now you'll be seeing only black, and the edges will be in white. Okay, and I can probably change this one. I can change this to something else, but I think wouldn't make sense. So now, why are we doing this edge detection? Because let's say if I have to detect a hand, firstly my computer should understand how does a hand look like. So that's the very reason we detect edges of different kinds of hands, different kinds of what do we say shapes, textures, and sizes of hands, in which edges play a very important role. So that is why I need to detect the edge of a hand first, the sketch of a hand, and then I can train my model, I can train my application and tell that, okay, this is how a hand looks like. So that is why we need to do this. So this is a very integral part of computer vision. So if you are becoming a machine learning engineer tomorrow, then you have to keep in mind that, okay, if I have to detect the texture of an object, edge becomes a very what do we say important part. Okay, so this is done. I'll kill this one. See, yep. So now I'll try to run another demo where I'm detecting. Yep.
Where is it? Yeah, now you'll be able to see my face, and this is detecting only contours. Okay, so as you can see now, my face is one of the biggest contours on the um on whatever field it is capturing. So this is where the contour is getting detected. Got it? So now if I put my hand over here, even my hand will be detected. It's not getting detected somehow. Okay, I think I have to put it. So it'll detect the biggest contour. Okay, so my face is biggest uh in comparison to the hand. So I'll just simply move my cam over here. I'll try to hide myself from my computer. Uh a bit more, a bit more, a bit more. Yeah. Come on. Okay. So I think I need to fine tune my code a bit so that it detects. Okay, just a minute. Oops. Yeah. Also, I hope you guys are able to see all of the screens, the output, the what do we say, code, everything. And of I hope I'm really audible because I'm using two devices. I just need to check the chat as well. Um, okay, Lalit says yes, audible. Okay, thank you. So, yeah. Let me go to this code. Okay, canny detection, face detection. Um, excuse me. Yeah. So as you can see over here, um, I'm writing a condition for largest contour by area. So that is the very reason the largest contours by area is by default my face. So that is why it is detecting and drawing a rectangle around it. So that is why it is doing this one. Scale factor. So I think I can change it to minimum, and now it will be minimum contours. So I'll quickly save this, and I'll close this one, and I'll try to run it again. Now it will detect minimum contours. I'll kill this one from the command line, and I'll try to run it again. Now it will detect minimum contours. Yeah, okay. As you can see, if I nod my head, it is also detecting the checks on my shirt. And if I put my hand, it will also detect minimum contours, the lines of my hand, the thumbs basically. As you can see, slowly this is detecting the gap between my fingers. So it is also detecting minimum contours now. So as you can see from here, it is what do we say, detecting the white part and the edge of my face. So this basically stands as a contour. And if I simply uh, simply face it to the wall. Okay, now this is a wall, and I put my hand. It detects the most minimum contour. I'll take simply an object. There's a wallet, and I'll try to draw a shape out of this thing. Try to draw a contour. I hope it detects something. Okay, this is plain, so it won't have any contour. I'll try to make an edge. Okay, so yeah, as you can see now, as you can see, slowly the contour on this shiny case is getting drawn. So I hope you understand how this is detecting it. Okay, so only the part in which the light is getting detected, and the dull part is not getting detected. So this is how it is working. So that is what basically contour detection means. The what do we say? Just a minute. Let me again check the mic because I'm worried if you guys are listening to me or not. Okay, cool, fine. Just drop me a thumbs up if you guys can see everything, if it is proper. Okay, cool. So moving ahead, again, let's check the code. So yeah, number one, uh, just like I told, I'll also put the presentation side by side. The presentation here, yeah. As I said, firstly, I'll put Gaussian blur. As you can see in both the code, in CV demo over here, this one and in this one, in both the codes, there is Gaussian blur. Where is it? कहाँ चला गया? यहाँ पे line number 24. So this is basically to reduce. Um, I think here I'm not doing Gaussian blur because I directly. Okay, here it does not make sense because I converted the image completely to grayscale. Okay, so here I simply used Gaussian blur, and here I added can edge detection. So Gaussian blur is to make the image smoother. Here it did not what do we say matter because the whole image was grayed off. So this is to make the image smoother, and then um, here is where I'm writing the code for contours. So if there are contours, do this. Yeah, I'll just show you the references of this. Where am I using? Okay. Yep. I'll change this back to max. So here, in the parameter, in the key, I'm simply using CV2 and checking the contour area. Okay, just a minute. Let me hover on this. Yeah, as you can see here, contour area is a pre-given method from the CV2 library, which helps us do this. And then I'm using CV2.bounding rectangle to basically create a rectangle around the area which is making a contour. Yeah. So yeah, as you can see, this area is making a contour, the light one and the dark one. So it is making a rectangle around it. That's it. Nothing much. It is pretty simple. Computer vision is not rocket science. And today, I think you guys saw it in just a minute. Let me show you another demo as well. Mm, so yeah, just like I was saying, it's computer vision is pretty simple, and what is it called? Emotion dot. Okay, cool. Emotion underscore demo. Okay, so the module was not on. Okay, anyways, guys, even we are running out of time, so I'll give you both all the three. What do we say? Code files along with the resources. I'll somewhere um put it on maybe GitHub or maybe somewhere. I'll post it somewhere and I'll probably give it to you. So let's do one thing. Let's make some other changes. Let's see what all can we do. We can make this gray. So I'll make it gray and I'll try to run it again. Let's see. Let's play around and see what happens. Okay. It's not grayed out. Okay, fine. So yeah, you guys can take this code just like I'm doing. Play around with it. See what is happening. And um, here, make sure that uh, you can change this one filter. There's actually cascade classifier which uses something called as har cascades. I call it har cascades. I don't know how other people pronounce it. So if you go inside this, you'll be seeing a lot of boilerplate code. Which would not what do we say make sense when you see it for the first time. So later if you go in, if you get a lot of information from the documentation and see how cascade classifiers work, then you might understand uh, how basically this classifier is working, how basically cascading is working. So um, that's it from the demo. Let me go back to my original screen and present the PP. Okay, got it. So yeah, again, going back on the explanation, just like we did, we made the image into a grayscale one and kind of tried to what do we say, figure out how the edge of the image looks like. So yeah, again, um let me repeat. So har cascade is basically something that irrespective of the scale of the image and the location, it can detect some sort of objects in the image. For example, in my face, it could have detected different contours like the eye, hands, etc., etc. So this is basically the tip of the iceberg when it comes to computer vision, but a very important thing. um okay.
Yep, I'm back. So, okay, let me reshare the presentation. Uh, Here you go. So, just like I was saying, number one, detecting the edge. Number two, detecting the contours, and number three, making some sense out of it. So we did all of this just to check how we can operate on an image, get some context out of it, and how did we approach towards it. I'm summing up everything. Number one, we simplified the image, we processed it. By what did I do? I used grayscale conversion, converted it into gray. Then I added Gaussian blur to smoothen it. Then the number three, I detected the intensity changes using Sobel operators. Now, it used something called as double thresholding to bridge to what do we say, classify an edge. Is it strong edge or a weak edge? And then finally, if a edge is broken, we simply bridged it from edges to the strong ones. Got it? So basically, if an edge is broken, let's say if I put my hand on the screen, it would detect everything all around, and if some of the in betweens are broken, it would simply bridge it. So that's it, guys. I think all of this would take some time to process, but in layman terms, this was, what do we say, a small example of computer vision. And if you go to bigger applications of computer vision, like let's say if you have to detect something very complex, then these will be the basic methodologies that you guys might follow. So detecting contours, detecting edges, and then detecting textures will be definitely will be on your list. uh, Whatever it is, like if you are making any kind of detection or any kind of segmentation algorithm, or whatever the computer vision application you're trying to make, these will definitely be on your list, because this is how the computer gets an approach towards the image. So there's how our computer is basically able to understand the image, and basically this is how even we should train our algorithm. So yeah, I think that's it. So if you have any questions still here, please put them in the chat, or else we can go forward. Yep. So I had two questions from Lalit, I did not take them. So the one of the questions was, can you integrate CV2 into a TensorFlow model, like when we run predict on a model? I think when we are using TensorFlow, yes, we can do that. We can definitely do that, but it depends on our use case. Why are we actually doing it? So then it would make some sense and give us more context. That is one thing. And there is another question. Can you show the output as gray as well so that we can see what the computer sees? I didn't get it because I think that is what we did. It was completely black and white. So that is how the output was, right? I didn't get that. Can you please fine tune your question? So, yep. Coming back to our CV2 thing. So this is what we did, and somehow today the demo worked. It gave us a bit of problem, but like yesterday we did not leave it unfinished. So, yep. So that's it. And another thing is AMA. Yeah, you guys were asking about AMA a lot of times. So, guys, it is on 6th September at 8 p.m. Today, I could have tried to take, but we already ran out of time. Um, we I think took a lot of time today. It was scheduled for 45 to 50 minutes, but I took an hour. So yeah, also we started late, so I think AMA cannot be done today. So let's schedule it on Friday night, 6 September 8 p.m. That is for sure, 100%. Get ready with all of your doubts and questions. Shoot them at me. If I'm not able to answer, definitely there'll be someone else to answer them. But yeah, we'll be doing it on Friday night. So that's it for today, guys. I hope you all got to learn something from today. And yeah, the demo worked somehow. uh, and if you were not able to understand anything, and if there is any learning gap, please feel free to ask your questions in the communication channels. And today's resources, Kaggle Learn resources, will be given in a couple of minutes. Just give me some time. Um, so these resources for week one, week two, and week three, all of them I'll put it together again, and I'll try to put them in the group. So yeah, and also the code which I showed today, the demo, I'll give it for sure. I'll try to put it on GitHub and I'll share it in the group. Just give me some time. I'll share all the resources. So that's it, guys. Thank you so much. Thank you so much for joining me tonight, and hope you all had got something to learn. I'll try to come up with something more interactive for the time series and for the AI ethics and for any other sessions if we take. Till then, thank you so much. Have a good night. If you have any questions, feel free to drop them in the communication channel in any of the groups. Doesn't matter. I'll definitely take them up. Thank you so much, guys.